Consider this ordinary annuity problem. If $120,000 is borrowed for a home mortgage to be repaid at a 9% interest rate over 30 years with monthly payments of $965.55, how much interest is paid over the life of the loan? Well, the total paid would be equal to the number of payments, 30 years of payments and 12 payments per year, or 360 monthly payments, times the amount of each monthly payment, $965.55. That works out to be $347,598, less the amount borrowed, which was $120,000. That works out to be $227,598. The $120,000, excuse me, forgot a zero there. The $120,000 represents the principal, so the difference between the total paid of $347,598 and the principal amount of $120,000, this $227,598, is interest that was paid over the life of the loan. While that's helpful to know, and by the way, gosh, that's a lot of interest for a $120,000 loan, right? But if we want to know for any particular payment how much of it goes towards principal and how much of it goes towards interest and how much the loan balance is at any point in time, we need to look at something called loan amortization. Loan amortization is the determination of the equal loan payments necessary to provide a lender with a specified interest return and to repay the loan principal over a specific period of time. And if we want to know at any point in time the balance, how much of it went towards interest and how much of it goes towards principal, we can look at a loan amortization schedule. So for example, what would the monthly payment be on a home mortgage of $75,000 at 12% interest to be amortized over 30 years? And what will the balance be after the second monthly payment on that mortgage? What about after the 20th payment? What about after the 100th payment? Let's look at an amortization schedule in an Excel spreadsheet. The first step in amortizing a loan is to calculate the monthly payment. For this problem, the principal amount is $75,000. The annual interest rate, the nominal interest rate, is 12%. We convert that to a monthly interest rate by dividing it by 12, or 1% per month. The number of periods, there's 30 years, and at 12 payments per year, 12 monthly payments per year, that's a total of 360 monthly payments. And then we can calculate the payment using Excel's payment feature, where we'd look at blue, the D4, the 1% interest, D5, the number of periods, C3, the principal amount, to arrive at our payment of $771.46. And again, this is negative because it reflects the fact that we are paying this, making this payment. That's a cash flow away from us in exchange for borrowing, having the cash inflow of $75,000. To calculate an amortization schedule, we begin with the payment. Is it the first, second, third, fourth, fifth payment? The beginning balance on the loan, the amount of the payment, how much that payment goes towards interest, how much of it goes towards repaying the principal, and then our ending balance, which will roll over to our beginning balance for the next period. So after we've calculated the monthly payment amount, we can begin to generate the amortization schedule. So for the first payment, we had a beginning balance of $75,000. Our payment of $771.46. Notice throughout the amortization schedule, the payment amount doesn't change. It's the same. The interest is $750, and we arrived at that by applying the 1% per monthly interest multiplied by the beginning balance. So $75,000 times 1% is our $750. And again, you can click on the equal sign there and you can see how that cell is calculated. Well, if the total payment is $771.46, $750 of it goes towards interest, so the amount of principal that's repaid on this payment is the amount of the payment, $771.46, minus the interest, which gives us a total of $21.46. Again, you can click on the equal sign here, and you can see exactly the formula for the cell and the color coding for the cells that are used. Because 2146 goes towards principal, our ending balance is the beginning balance, $75,000 minus the 2146, and that gives us an ending balance of $74,978.54, and that amount rolls over for the second payment as the beginning balance. And we do this calculation again. So for the second payment, the interest is 1% of the beginning balance of $74,978. And again, I'm going to click on the equal sign here so that we can see the cells that are used. And then again, the amount of principal repayment is the amount of the payment, $771.46, less the amount that goes towards interest, or $21.67, and we now have a new ending balance. And then we'd repeat this process over and over again. The nice thing about Excel is once you've done it once, you can just copy and paste for however many periods you want to do. Now notice what happens to the amount of the loan payment that goes towards interest. It began with the first payment at $750. By the second payment, it went down a little bit, $749.79, so it decreased by 21 cents, and the amount of principal repayment increased from $21.46 to $21.67. It increased by 21 cents. So from payment 1 to payment 2, the amount of interest decreased by 21 cents, and the amount of principal repayment increased by 21 cents. And as we scroll down, we can see that over time, the amount that goes towards principal is increasing, and the amount that goes towards interest is decreasing. So if we want to know what the loan balance was after the 20th payment, well, that 20th payment, after we make that payment, our loan balance is going to be $74,527.48, and $25.93 went towards principal, and $745.53 went towards interest. In the green, we have the amount that goes towards interest, and in the purple, we have the amount of each payment that goes towards principal. Here on the horizontal axis, we have the number of payments, and on the vertical axis, we have the amount of the payment that's going towards either principal or interest. So the total of the payment, recall, is $771. So we could add this amount and this amount. That would be the total payment. And we can see over time that the amount that goes towards interest is falling, so that when we get to 360th payment, it's almost all principal and no interest, and the amount of principal increases over time. And for this 30-year mortgage, 360 payments, at payment number 291, the amount that we pay towards principal equals the amount that we paid towards interest. So in other words, this 30-year mortgage, 360 monthly payments, you have to go all the way to payment 291, which is somewhere around 24, 25 years, until you get to the point where most of your payment is going towards principal and relatively small amount is going towards interest. So obviously, if you're interested in repaying this loan, you want to get to this zone where the line's going straight up and down, or almost straight up and down, as soon as possible. Because in these early years, there's not much slope to that line. There towards the end, the slope gets quite steep. And then we can look at our loan balance by payment. So we can see again, or somewhere around payment 200, 298, that the slope is quite steep. In other words, we're paying off the loan really quickly. This is why adding an additional principal repayment to your loan payment, so for example, for this loan, the loan payment was $771. If we could add a little bit extra, $25, $50, $100, $200, we can more quickly get ourselves to this region where we're really repaying that loan quickly and save a lot of money on interest, because as we reduce the principal amount, there's less interest, because interest is earned on the outstanding balance. So the quicker we can pay down that balance, the less future payments are going to go towards interest, and the more the future payments are going to go towards principal.